I don't mean to interrupt you, but just in case people who are listening don't understand what a fatty acid is and a free fatty acid, would you just explain basically what they are and how they're used?
A fat such as butter or lard or corn oil, most of them consist of about 18 carbon atoms in a chain with oxygens on one end making it acidic, and the rest of it either just plain carbon and hydrogen, or occasionally with the hydrogens removed. That's called an unsaturated fatty acid, with a carbon chain interrupted by pure hydrogens. And those chains are attached to a glycerin molecule, 3 carbons, technically an alcohol that forms an ester with these free fatty acids, blocking the acid group, which makes the free fatty acid water soluble to some extent. And when the glycerin, which is also very water soluble, is combined with 3 fatty acids, it becomes very water insoluble. Mm-hmm. And that is the form in which it's stored in the fat cells, because you just form a drop of pure fat in the cell, and it's very reluctant to diffuse away because of its insolubility. So when you need energy, you have to activate enzymes that break the free fatty acids loose. When that happens from stress or hunger or fasting, these free fatty acids get into the bloodstream and enter cells and are available as energy production in the absence of glucose.
Right,
but the trouble is that process also tends to keep the stress going if the free fatty acids are unsaturated. Those are more water soluble, and when they're polyunsaturated, like from corn oil, safflower oil, and so on, those have a further stress-inducing action that tends to keep the breakdown of fat going and the stress reproducing itself.
Mm-hmm. Normally, if somebody was on because I know people that are listening who've listened to you before know that you're a great advocate of saturated fats, butter, and coconut oil in particular, and you're very much against the negative health impacts of the liquid oils and fish oil in particular. If somebody's consuming a lot of butter and milk, whether it's full fat or semi-fat, and coconut oil, the fats therein, when they are stored as fat, they don't have the same destructive, if you like, or oxidative effects when they're liberated.
If you store a very saturated fat, like the Indians make ghee by removing the water-soluble material, right. A pure fat oil, or coconut oil, which is 98% saturated, those things keep for years without breaking down. But if you leave a bottle of safflower or corn oil or linseed oil open, within hours or days, you can detect spontaneous oxidation of it in the air. And that happens at body temperature with the high oxygen content of your blood. Happens very quickly with the polyunsaturated fats. Mm-hmm. But interestingly, the biological oxidation is pretty much the opposite, because if you have 2 types of fat circulating in your bloodstream, one saturated fatty acid and one polyunsaturated, your muscles will be able to oxidize the saturated fat preferentially, and the polyunsaturated fat tends to go into storage if you ate more than you can oxidize. So it tends to be fattening if you eat a little extra of the polyunsaturated, because it stores more easily.
Okay,
but your fat cells can also oxidize saturated fat. And so they live on the saturated fat that they have stored. And so over the years, stress is more likely to release the polyunsaturated fats, making stress an increasing problem with age.
Right. So that's the thing behind what you're describing now as the component-free fatty acids. If somebody's eating a lot of saturated fats like butter, ghee, or coconut oil, then they're not going to liberate the same free fatty acid that they would if they were consuming polyunsaturates in their diet.
Right.
Yeah.